Trigonometry day 2. Our trig functions from yesterday. Does anybody remember the 3? What was the first one we talked about? Started with an S. Sine. S-I-N-E. What was the abbreviation for sine? Sin, S-I-N, and the ratio that is formed with using sine. Opposite over hypotenuse. Okay, we'll do it a little different. I will just run through these notes. Cosine is my next one. Cosine, its abbreviation is COS, and that function or ratio would be your adjacent over your hypotenuse. And then your last one is your tangent. And the abbreviation there is tan, T-A-N, and its ratio is your opposite over your adjacent. You guys have already copied this into your notes. If I remember from yesterday, my steps are to first identify the angle that it wants me to build my triangle off of. So if I look at this first column over here, what angle does it want me to build the triangle off of? It wants me to use A. So Mr. Schote puts a little dot next to the angle. Step 2 was to label our sides. Across from the right angle is always going to be my hypotenuse. I've noticed students struggling with labeling their sides. The hypotenuse ought to be one we never struggle with because it is always opposite the right angle. Then, the next thing I would tell you to do is to go across the triangle, and that becomes your opposite side. That's your opposite side. In our notes yesterday, we wrote down opposite means across the triangle. Then the only other side that's left to be labeled is our adjacent side, and on my triangle, the only side that does not have a label is this one right here that says the distance between A and C, which is 3. That's my adjacent. Thank you. So now I have my angle identified, I've labeled my triangle. My next step is to build those ratios. For sine of A, sine was the opposite over the hypotenuse. My opposite side was 4. My hypotenuse is 5. I've built the ratio, 4 over 5. My next one is cosine. That is the adjacent side, which is 3, over the hypotenuse, which is 5. And then my tangent ratio is the opposite, which is 4, over the adjacent, which is 3. And now I have all of my ratios based off of angle A. The next column wants me to build it off of angle B. So with a different color pen, I put a mark next to B. That next step was to label my sides, and across from the right angle still remains my hypotenuse. Across from my angle, across the triangle, is now my opposite side. And then next to my angle is my adjacent side. So notice that some of my sides flipped. What was the opposite became the adjacent. What was the adjacent became the opposite. My hypotenuse did not change. Sine is the opposite over hypotenuse. So now the opposite side is 3. My hypotenuse is still 5. Cosine is the adjacent, which is now 4 over the hypotenuse of 5. And tangent is the opposite, which is 3 over the adjacent, which is 4 now. Everyone have that? Okay. I want you to solve this next set yourself. So draw it in your notes and solve it yourself there. Okay. Here, same 2 columns, sine of A and then sine of B. Sine of A is opposite over hypotenuse, which would have been 12 over 13. Cosine of A would have been the adjacent, 5 over hypotenuse of 13. Tangent of A would have been 12 over 5. Hopefully that's what you got. Sine of B would have been 5 over 13. Cosine of B would have been 12 over 13. And then the tangent of B would have been 5 over 12. Everyone got that? Good, good, good. Okay, copy these two in your notes. Okay. I'm going to teach you how to actually solve some triangles using trig functions. And probably better stated, how to solve for a missing side using the trig function today. Everyone needs to take their calculator. And on your calculator, I'm going to see if I can do this. Calculator. You're going to push second plus 7, 1, 2, and enter. That should clear your calculator. And then up in the blue area, 7 plus 7, 1, 2, it should say radian. You may see where it says radian up here, okay, if you're using one of our school calculators. Now I need you to push mode, and then go down to 2 spots where it is flashing over the word radian, and push it over to degree, where it's flashing over degree. Push enter and then clear. Now you are in degree mode. If you're looking at one of our school calculators, up in that blue area, it says degree. Okay? When you're using trigonometry and the functions of them, you need to use degree mode. The other thing I want you to notice is that 2 places above 7, 8, and 9. So go to 7, 8, and 9. 2 places above, or 2 buttons above, you will see there's a sine button, a cosine button, and a tangent button. And we're not going to talk about this today, but even if you were to push the second and then look at those, in the blue, it's actually sine -1 to the power -1, cosine to the power -1, tangent to the power -1. That's called inverse trig. We'll talk about that when we get back from spring break. But if we're looking at this problem, we're going to use a trig function to solve for x. The first thing I need to do is decide what angle did they give me other than the 90-degree angle. 28. I'm going to put a dot there. I'm going to identify that angle they gave me. From there, they gave me some information about my sides. What 2 sides did they give me? They gave me the hypotenuse and the There's three sides of triangles in trigonometry: opposite, adjacent, and hypotenuse. They gave me the hypotenuse, and they gave me what side? They gave me the they gave me the opposite. Across from the angle, they gave me the opposite. Okay, so what function of trigonometry uses opposite and hypotenuse? Sine does. Good job. So we're going to write the sine of the angle, 28 degrees, is equal to the opposite over the hypotenuse. Okay. Everyone have that? What's happening to the x right now in this equation? It's being divided by, what would be the opposite of dividing by 19? We would multiply by 19. So I'm going to come here and times both sides by 19. When I do that, those two 19s will cancel each other out, and I'm left with 19 times sine of 28 equals x. And I can actually type that into my calculator. 19 sine of 28, close parentheses, and I get 8.9199596 or 6929. All I care about is us getting one decimal place past, or one place past the decimal point, which is going to give me x equals 8.9. Everyone have that? Okay. Now, Shania, don't be coming over here asking for help with you sleeping over there. Like she could hear me. If she's sleeping, how's she going to ask me for help right now? She can hear me. Oh, now she's awake. Okay. Let's do this example. What angle did they give me? What angle did they give me? Ooh, are we awake? 41. What sides did they give me? They gave me the opposite and the, whoo, boy. Where is my hypotenuse in every right triangle? I want all eyes to look at me. I want to see all your eyeballs. Shania. I don't see him. I still don't see him. Say this after me. The opposite side from the right angle is the hypotenuse. Say it again. The opposite side from the right angle is the hypotenuse. Where is the hypotenuse? Opposite the right angle. Y'all scare me when I look at this triangle and I look at the opposite side from the right angle, and is there anything there? No. So they didn't give me the hypotenuse. They gave me the opposite side of the triangle from the angle and the adjacent side. What trig function uses the opposite and adjacent? The tangent does. So the tangent of the angle, which is 41 degrees, equals the opposite over the adjacent. What's happening to the x? It's kind of a trick question. Nothing's happening to the x right now. The x is actually dividing 32, right? The x is doing the work. We want to give the x a break. And we're going to do that by taking the x and swapping it with the other side of the equation. So our problem is now going to look like x equals 32 divided by the tangent of 41. Okay? They gave us the angle 21 degrees. What side did I just point that arrow to? Thank you, the adjacent. What other side did they give me? The hypotenuse. Good job. What function uses the adjacent and the hypotenuse? Cosine. So the cosine of 21 is equal to the adjacent over the hypotenuse. How do we solve this one? What's happening to the x right now? It's being divided by, so I'm going to do what? I'm going to do the opposite of that and multiply it by 26 on both sides. That leaves me with 26 cosine of 21 equals x. And we can type that into the calculator. 26 cosine of 21, close parentheses, and get 24.3. Beautiful. I have nothing else for you today as far as notes go.